I'm gonna tell you a story. About a year ago, when I was building my hexapod robot, I started to be really interested in robotics, especially bipedal robots. So I saw for the first time robots like Atlas from Boston Dynamics, and this is the coolest robot ever. It dances, it does dynamic stuff, and it's just really cool. So I looked at some simpler robots that I would be able to build in my lifetime, in theory. I found Cassie, which is just a robot with 2 legs and nothing else. It's the simplest bipedal you can make. I started reading some work on this robot. It wasn't that bad, and I set myself a goal that in my lifetime I would build a bipedal robot that would be dynamic. I think that the hardest part about these robots is the controller. If you don't know what a controller does, basically if you took this bipedal robot and just coded the movement of each leg and let the robot walk, it would just fall over. The robot needs to be able to respond to disturbances. For example, if you push the robot, it shouldn't fall over, it should recover. And that's the role of the controller. Just balancing the robot upright, it's a very hard task. You might imagine that designing these controllers would be extremely hard, and it is. But we can circumnavigate this by using a neural network. You might be wondering how these robots are able to learn walking and doing backflips. Take this with a grain of salt. This is a neural network. It's the brain of the robot. And what it does is you input the command, for example, walk forward, and also some sensor data. In order to be able to walk, the robot needs to know where his legs are, if it's tilted and things like that. So you input these 2 things and it calculates the motor angles. This sounds great, but the question is, how do you get this neural network? Well, creating it is actually quite easy because it's just a bunch of equations, but the problem is having it set correctly. The neural network is defined by weights and biases, which are just a bunch of numbers. And if we find these numbers, the neural network is going to behave how we want. We do that by first setting these numbers randomly. It calculates some random motor angles and we simulate what the robot does. Based on the simulation, we need to tell the neural network how well the robot did. We do this by introducing a reward function. We can add a score to the robot based on how well it's doing. For example, if the robot falls over, we take off points. And for each second the robot stays upright, we give it some points. This way the robot would probably learn to just stand still, but we want it to walk. So we can also add some points for when it's following the command. For example, when you tell it to move forward with some velocity, if the robot follows this velocity, we give it reward too, and that way it should learn to walk. Based on this reward, the policy is gonna update the weights and biases. And doing this simulation many times over, it should learn the correct behavior and follow the commands. After training the robot in simulation, we take the neural network and surgically install it into our robot, and it should work in real life too, if the simulation was realistic, that is. Training a robot this way is called reinforcement learning. It's very computationally expensive, and you need a really good simulation if you want to transfer this to real robots. I started to look into some programs which I could use to simulate these robots. The first thing I did is I found a bunch of Python tutorials. I watched some of these tutorials, I tried to run them, and it never worked. There was always problems with compatibility. I've tried this like 5 times. I even tried this metal robot. This was outdated too. So this was really discouraging. I couldn't even run pre-made scripts. So I said fuck it, I'm not gonna waste years of my life, and I stopped trying. But then, about a week ago, we had a class and the teachers showed us some of these programs. I actually got it to run. He showed us how to install it and it worked. It still didn't move me quite as much, but then he showed us this robot, and how can you say no to him? He showed us this program called Isaac Lab, which promises high fidelity, which means that the simulation is really accurate and you can actually transfer this to real robots. It's from NVIDIA and it's free. This kind of motivated me. From that point on, it was all the time in the back of my mind. I could potentially simulate a bipedal robot and sometimes in the future maybe even implement it. One day I just got to my PC, started installing it, and this is where I'm at right now. I spent 3 days with this program and I'm gonna show you my progress. Simulating these robots is a lot of fun, but if you want to build one in real life, you're gonna need some PCBs. So this is my sponsor PCBWay. They do a lot of manufacturing, like CNC machining, injection molding and 3D printing, but I mainly use them for the PCBs. I've used them for my hexapod robot, for the robotic arm, and I'm gonna use them for my robotic dog project. If you buy PCBs that are under 100 by 100 millimeters, you can get 10 of them for $5. And if it's your first time using PCBWay, you can click the link in the description and you will get a $5 discount. On day 1, my goal was to install Isaac Lab. That's all I wanted to do, because it's quite hard. So Isaac Lab runs on Python, so you need to have Python installed. And for me, to make the coding simpler, I use PyCharm. You can also use Visual Code Studio. So I just googled Isaac Lab and I found this GitHub page where there's a tutorial for the installation. It's not that straightforward to install it, so you even need a tutorial for that. Isaac Lab installation, then pip installation. With pip you install all the Python things. And here's the tutorial, so I just followed this. By the way, if you want to see this in more detail, check out my Twin channel. So I just went through this, installed everything. So now I'm in the Isaac Lab directory. After that I can use this command, but before it you also need to put like backslash and dot. Fuck. Okay, it's first dot and then backslash. Yeah, now it's starting to open up. So it's gonna open the Isaac sim and it's gonna open an empty environment. Yeah, it's open. So after this, you can start training robots. I'm gonna train a robotic dog to walk. So I just copied this test command, and by these commands you can set what type of training you want. So if it's headless, you're not gonna see the robot dogs. It's just training the robot dogs without rendering them, which is good because it's faster to compute. You can also type other stuff, like number of environments. So here there's gonna be only 8 environments, which means 8 robotic dogs. Let's see what it does. And the robotic dogs have been loaded. I think it's the green arrow, that's the command. So we want the robotic dog to walk along the green vector. And the blue vector is the actual velocity of the robot. And it's at the start of the training, so right now it's really bad, and over time it should improve. When I first got here, I was surprised that the camera is so bad. So what you can actually do is, instead of follow mode world, you can go for the robot. So if you just click on this, left click and hold, and go left or right, you can sweep through the coordinates. So I'm gonna put it really close to the robot. Z coordinate. Fuck. Yeah, now we can really see the robotic dog. Very nice. It's also nice to see the environments they have. They are training robot dogs on different terrains, so they will be more universal. If you just trained it on a flat ground, it wouldn't be much useful when you want to walk upstairs. So this was the first day. To get to this point with the installation and everything, I think it took 5 or 6 hours. What I also liked about my first day with this program is that I recognize this robotic dog. It's really cool to see these real-world robots in this simulation. They also have the Spot robot, I think, from Boston Dynamics, and the Cassie. I was surprised by that. So this was my first day, and I was hooked, to be honest. At day 2, I wanted to import some models from the community. So I searched some tutorials on YouTube and found this gem. So this guy is called Robot Mania, what a name. It's a great tutorial, really watch this video. He installs the Isaac Lab, then defines the problem. So you have this robotic dog with wheels and you want to balance it on the back wheels. After I downloaded the files, I just imported the project, and these scripts were already outdated, even though the video is like, holy shit, 2 months old. All I had to do is switch this for Isaac Lab, and after that it worked. Also, one other thing I needed to change was the path. Just found where I had the USD file, which I think is the physical model of the robot, but I'm not sure. I've just followed the tutorial. These are the commands I used for training. I just ran the script. This is what it looks like when you're running the training phase. You get the iteration number, the time steps, and this is the reward function. This number, the 79.9, that's how much reward the robot is getting. The value doesn't matter itself, it just matters that it should increase over time. I've trained this robotic dog a bunch of times because I wasn't quite happy with the results. So this is where it ended up. It's obviously shitty, but it's better than the start. It's using its front limbs, but it still falls over. Yeah, this is not revolutionary. I looked into the code a bit and started changing some of the parameters. The robot gets some reward based on how long he stays alive. Then he gets punished when he falls over. So I played with these weights and didn't get better results. I still don't know how I can add different types of rewards. I just changed the weights. So that's what I'm gonna look into next. There's also this PPO file, which is for the learning. So this is the neural network. One hidden layer with 32 neurons and a second one with also 32 neurons. I've tried to increase it, decrease it. I've played with that, but I haven't got any better results, to be honest. I think if I let it train for a longer time, it would find a better solution, but this is where it got stuck. At day 3, I wanted to import the Cassie robot and try to train that to walk. As it so happens, it's already in the Isaac Lab folder. It learned to walk. You can see that it tracks the velocity vectors pretty well. It's really cool to see that the robot learned to walk just by doing many simulations. For a class I'm taking, I'm probably gonna have to make some project like a humanoid that learns to walk. So I'm gonna upload that should be interesting. And for now I'm gonna focus on my other projects and I'll probably get back to this once I have my robot dog built.